6-4. We're going to do all of 6-4 in one day. It's going to be a lot. It's going to feel like a lot. And we're going to learn a new way to graph today, and it's called polar graphing, but today we're just going to kind of focus on polar coordinates. It's fun. Polar graphing is one of my favoriteest things ever. Hold on. Let's first talk about the polar coordinate system. Okay, polar system. And polar coordinates, what's going to happen is you're going to have a point. I don't know why they call it point O. They call it point O. I'm not going to call it point O. So here we go. Let's say that you have, that's like the x-axis, and you go an angle opening of, we'll call it theta, and you go out to a point P. Okay? Now usually we mark this point P as x and y. No longer. Not no longer, but in polar graphing we don't label it like that. Polar coordinates are labeled r theta. Okay? So P is equal to r theta, where r is the distance from the origin. All right, so we'll call this point O for origin. It's fine. I don't mind that. It looks like a 0 to me, but it's O. Okay? So r is the distance from O to P. Now, what did we call that distance a few days ago? It starts with an M. Magnitude. Nice job. It's the magnitude. So if you're going to think of this as vectors, which you can, try and do that. It's just the magnitude. Think of 0 to P as a vector. And so r is that distance there. Theta is going to be the directed angle. It's direction angle. Direction angle from where you're used to having it from, the x-axis. It's not bearing, it's not from the north, it's a directional angle. And so what we do is, in our polar graphing paper that I just showed you a minute ago, this is how it's going to look. You're going to have a plane like this, okay? This is called the polar axis. Polar axis. It's no longer called the x-axis because there is no x, there's no y. You can't call it the x-axis. This axis is the axis theta equals pi over 2, because that's where pi over 2 is, if you're going to go from the polar axis to pi over 2. And then here's how we graph. We do this. You go a distance of 1 in each direction, and you draw a circle. Okay? Then you go a distance of 2 in each direction, and you draw a circle there. This is like making grids on the XY plane. And then you go to a distance of 3 and you draw a circle. Kind of drawing it like a dash line almost. Okay? And so if I were going to plot some points, this is how you would do it. So here we go. Number 1. I'm going to plot a bunch of points on here. Okay? I'm going to plot point P. I'm going to call P the point 2 pi over 3. Okay. What that means is r is 2, so the distance from the origin is 2 at an angle of pi over 3. So you got to be pretty good at, your angles and radians and degrees. It doesn't matter. So I'm going to go out to the second circle, because that's a distance of 2 from the origin all the way around. And I'm going to go to an angle of pi over 3. And I'm going to plot my point, and that would be point P. Right there. Do you see that? So r is the distance from the origin, so I end up on circle 2 at an angle of pi over 3. Okay, let's do another one. Let's plot point Q. Q I'm going to call -1, I've messed with you, 3 pi over 4. All right. -1, you have to think of -1 as in the opposite direction. It changes your direction. You can't go to a negative radius circle, but it's going to make it the opposite way. So if I were to graph this one, I would go over here to 3 pi over 4, which is in what quadrant? 2. And I'd go the opposite direction, and I would plot point Q right there. That's Q.
So you
Can you say that one more
reflect it?
time?
I'm sorry, what?
So you almost like reflect it?
Yes.
Can you say that again?
Yeah. So if let's talk about the point +1, 3 pi over 4. Okay? +1, 3 pi over 4 is at 3 pi over 4, so that would be this angle here. And 1 would give me right there on my unit circle, distance of 1. But this is not 1, it's -1. So what does that do? It makes you go the exact opposite direction. Just like when a vector, when you multiplied it by a negative number, it went in the opposite direction. Same thing here too. Okay? All right. How about one more? We'll call it R. Let's plot R, and R is going to be 1, -45 degrees. So let's plot 1, -45 degrees. Huh. Yes, same place as Q, right? So I go to 1, I go to -45 degrees. This is the same thing as point Q. Now, that brings up an interesting topic. You know how when you're on an XY plane and you plot the point 2, 3? There's no other way to plot that point. There's no other point that's exactly the same. In polar graph, there's an infinite amount of points that are exactly the same. It's pretty interesting, huh? So that brings us to number 2. So they're going to give you a point. Let's say point P is 3 pi over 3. Now let's go pi over 6. We already did pi over 3 today. 3 pi over 6. And what we're going to do is we are going to find 2 additional points. 2 additional points that are the same point. The same point. Okay? 2 additional points written in different ways that are exactly the same point when you graph them, just like what we did just a minute ago. Okay. So, here we go. We could do this. There's an infinite amount of answers to this. Okay? You can go around the whole thing a bunch of times. I might ask you to make R a negative number, so you'd have to figure out how to do that. Okay? So 3 pi over 6, what I like to do is I would like to graph that real quick, just because so I can see it visually. So I would go out to 1, 2, 3. I'd go out to circle 3, which is out here. And I would go to pi over 6, which is 30 degrees. And so there it is, right there. There's point P. Okay? All right, so I can also say that point P is 3, and then I could do a negative angle. What would that be if I did a negative angle? It would be negative, anybody know? Negative 5 pi over 6? No, wait. Negative 11 pi over 6? Yeah? It's been a little while, huh, since we've done radians. Negative 11 pi over 6. Remember, 11 pi over 6 would go almost all the way around, but it would be a pi over 6 short. Negative pi over 6. What if I said, okay, you have to have negative 3 now? There's a couple answers that you could have for this, actually an infinite amount of answers. But one of them would be that you're over, you're
5 pi over 6.
5 pi over 6? Negative. So you're over here. Actually, you're not right there. You're right about here. Okay? And so, yeah, you would want to say this angle, which is negative 5 pi over 6. Was anyone thinking a different one?
7 pi over 6.
7 pi over 6 would also work, too. That would go in the positive direction there. Yeah, so there's a lot of different answers. 7 pi over 6? 7 pi over 6 it starts here, and it goes all the way around over to there. The negatives don't cancel out, no. So if I went to negative 5 pi over 6, I would be over here in this quadrant. But because it's a negative 3, it puts me back over in quadrant 1. Makes me go the opposite direction. So if I wanted to, I could also say negative 3 and 7 pi over 6. I kind of don't graph these like as going out to -3 and then doing the angle. I usually do the angle first and then go the opposite direction for 3. All right, here we go. Part B. So that's a little introduction into what the coordinates are. Now we're going to do some conversions. Conversion. Okay, so our conversion is going to be that we want to then write this point right here, 3 negative 11 pi over 6, as an xy coordinate instead, because that's what we're used to. That's what we want to get back to, rectangular conversions, okay? So if you have a point out there in space, we'll go ahead and call it P. Point P. It got really cold in here, huh? I'll shut the door. Let me pause this. P. Let's say P is our point R theta. But if I took P and I said, no, that's not on a polar graph, it's also the point XY. Do you agree? Of course you agree. Yeah. They're the same thing. So how are we going to get from one to the other? Because they're very different when you write them. Well, let's go ahead and do some trig. Here we go. Go ahead and drop perpendicular down. So don't do it. So this right here is R, and this is theta. And in this triangle, I also have X and I have Y, because those are the other ones. And so we can say that when we're trying to convert from one to the other, we can say that X, where am I going to write this? Right here. X is equal to R cosine of theta. Okay? Why? Ooh, good question.
Yeah. Y is equal to something.
And yeah, okay. So go ahead and tell me what the cosine of theta is in this triangle right here, using SOHCAHTOA.
X over R.
Perfect. So let's solve for X. Multiply R to the other side.
Okay.
Yeah. 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 You know, you're so good. You don't like me just to tell you, oh, it's equal to that. So yeah, so do cosine of theta is equal to adjacent over hypotenuse, and then go ahead and solve for X. So X equals R cosine theta. All right, what does Y equal then? Well, the sine of theta is opposite over hypotenuse, so Y would equal R sine theta. Okay, that's a conversion. That's conversion given R and theta. You can come back and give me what X and Y are. Now the other way is kind of the same thing. Let's go ahead and write an equation with R in it. Then using Pythagorean theorem, we can say what? X squared plus Y squared equals R squared. And using, to find out what theta is, we can say that the tangent of theta in this triangle, what's the tangent of theta?
I agree.
No? Tangent of theta is Y over X. Yeah. Y.
Boxes you're not using?
Boxes?
Yeah.
No. I don't think so.
Okay.
Okay. Tangent of theta is Y over X, right? SOHCAHTOA, opposite over adjacent, Y over X. All right, so here we go. We are now going to do some conversions. So number 3. Number 3. We're going to take a point that's in polar form. We're going to change it into its rectangular form. So here's my point. It's 3, 5 pi over 6. I want to find out what the coordinates are for this in just a rectangular coordinate xy. So if I told you to graph 3 5 pi over 6, you're like, that's hard to do. I want to see what x and y are instead. This is what you would do. All right, so I gave you formulas that you're going to need to know, okay? If you forget them, draw a picture. Draw a picture and do it that way, okay? So x equals, I need to find out what x equals, and I need to find out what y is. So I told you that x equals r cosine theta. R cosine theta. So 3 times cosine 5 pi over 6. Can I tell you something real quick? Because I know a lot of you guys are like, this is so much. Think of these as vectors. Okay, I know some of you don't like vectors, but do you remember what vectors were? It was the magnitude, cosine theta was our x coordinate. And then the magnitude, what? Sine theta was our y coordinate. It's the same thing. If this is equal to x and that's equal to y, x is equal to magnitude. Magnitude's 3, right? That's the length. And then theta is our directional angle. So it's really nothing new. It's just written differently. Okay, so here we go. 3 cosine 5 pi over 6. You're going to need to know what the cosine of 5 pi over 6 is. So you go to your unit circle. And pi over 6 is right here. This is rad 3 over 2, 1/2. So then the cosine of 5 pi over 6 is what? Perfect. Negative rad 3 over 2. So then that would be negative 3 rad 3 over 2. Okay? And now let's find out what sine, the y value is. The y value is 3 times the sine of 5 pi over 6. So I'd go over here to pi over 6, which is this angle right here. Sine is the y value, but I'm over in quadrant 2, and in quadrant 2, it's 1/2. Perfect. So you get 3 times 1/2, which is 3/2. All right, now let's put it all together into one coordinate. So the point 3, 5 pi over 6 is also the point negative 3 rad 3 over 2, 3/2. There you go. We just converted it. What's that? It is. Yes, I'm so glad you said that because people are like, I hate polar graphing. It's so hard. It's actually, this point is a better point to graph than that one would be. You are correct. It makes things cleaner and simpler and more beautiful. All right, should we do another one? Another one. Yeah. Letter A, letter B, another one. That was fun. Okay. I did. He's doing great. All right, so let's do negative 2. Let's put a negative in here, and negative 200 degrees. Now, here's the thing. When you see something like 200 degrees, that's not one of our 30, 60, 90, 180, it's not one of those famous. So, you can do this in decimals. You can round, you can use your calculator. Oh, love it. All right, so this will be to 2 decimal places. Okay. Now, if it's, one of your pi over 6, pi over 3, 30 degrees, it's going to be an exact answer. So you need to know the unit circle. 200 degrees is not one of our angles that we've memorized on the unit circle. So here we go. This is going to be easier for you. X is equal to, negative 2 times the cosine of negative 200 degrees. The only difference is, if you think of magnitude, magnitude is never negative, but it just makes you go in the opposite direction. So go to your calculator. Make sure that you are in degree mode, and do negative 2 times the cosine of negative 200. And that gives us 1.88. 1.88. And then we're going to plot this because I want to see where this is at. And then y would be negative 2 times the sine of negative 200 degrees. Negative 2 times the sine of negative 200. Gross. Gives us negative, I wasn't expecting that, 0.68. All right, so it looks like we're in quadrant 3, right? They're both, oh no, I'm sorry. Quadrant 4, right? X is positive and y is negative. All right, let's see. Let's plot this negative 2, negative 200. So negative 200 degrees, where is that? That's in quadrant 2? Yeah, so we go 180 and then a little bit more. So we're over here, but the negative 2 tells me that I got to go negative 2 in this direction. So that would be point Q, which is 1.88, negative 0.68. Pretty good. Nice. Wanted to make sure. Make sure it happened. Oh, there's a lot. Yeah. I still have you for like 12 more minutes, and I'm going to use it all today. Number 4. Okay, now we're going to go the other way. Number 4. We're going to go from rectangular now to polar. Okay? So those were, I was given a polar point, r theta, had to change it to xy. Now I'm going to be given a point in x, y, and I have to change it to r theta. All right, I'll give you an easy one, and we'll then, they're both kind of easy. Here we go. So let's say our point is the point -1, +1. Okay? Now, you know you don't want to memorize a bunch of stuff, right? I don't blame you. You don't need to memorize a bunch of stuff. This is what you do. You go to -1, +1, okay? And you're going to find out what r is, which is the distance, the length here, and you're going to find out what the directional angle is.
You just soak toe it up.
You can soak a toe it, but you don't need to on this one, because what is that angle? 45 degrees right here, so it's 3 pi over 4. Okay? Your 1 and your -1 are exactly the same, which makes this a 45-degree angle in there. But it's the directional angle, so make sure that you remember from the x-axis. You could have also gone this way if you wanted to. There's an infinite amount of points that are the correct answer. And then how do we find out what r is? It's just the magnitude. So you just do r equals the square root of -1 squared plus 1 squared. See, because you look at that and you're like, oh man, I have so much to memorize. But you don't. They're just vectors. And so you have r theta, so that would be the square root of 2, 3 pi over 4. Nice, huh? And those are the same exact points. Gorgeous. Let's do one more of those. Letter B. Let's find the point Q, which I will call -3, 0. -3, 0. Once again, you know there's going to be answers will vary. So if I go to -3, 0, where's that going to take me to? Well, the degree or the angle is 0, so that's here, but I need to go -3, so I'm over here. Okay? What is that point? Don't even worry about all the other stuff. What is that point in x, y? -3, 0? Wait. Did I do it wrong? Oh, I'm sorry. Yeah, we're going to polar now. You're right. So this one is -3, 0, which is right here, and I need to find out what r and theta are. You're right. I was thinking it the other way. Dang it. Okay, so what's r and what's theta? R is 3, theta's pi, or 180. I would accept 180 too. That's fine. I would accept -pi. I would even accept 0, -3 as an answer, or -3, 0, because that would be 0, -3. I know, it's the same point. Weird, huh?
Except 3 pi.
3 pi, I would. That's gross, yeah. Okay, last part. Part C. Okay, so far, all we've done are just points, you know? I haven't given you an actual equation and what it looks like. So we're going to have some equations. This is going to be leading us into what we're going to do next week, Monday and Tuesday. So we're going to graph things like this. R equals, what number is this? 5? R equals 4 cosine theta. Okay? We're going to graph this, and we're also going to write this. We're going to convert this into its rectangular form. So go ahead and get your calculators out. And this is going to maybe be your first polar graphing that you've ever done. It's exciting. Some fun graphs out there. You do? Math goosebumps? Love it. All right, so go to mode and make sure that you are in radian mode. Radian mode, and we're going to change over to polar. Polar. Zoom in. Okay. Polar. So now hit y equals, and look what it is. It's r equals. Ooh, so exciting. And we're going to graph r equals 4 cosine theta. R equals 4 cosine of theta. Hit zoom 6. It is. It's a circle. It doesn't look like a circle because of that, you know, that same thing, that window. R equals 4 cosine theta. So it's a circle. It's not centered at the origin. Just, you know, shift it over a little bit. And I'm going to show you how to write this in its rectangular form. Okay? All right. So this is what you're going to do. This is really weird, so pay attention to this, okay? To get this into its rectangular form, we need to have x's and y's. Now the thing is, you need to know that x equals r cosine theta, and y equals r sine theta, and x squared plus y squared equals r squared. Okay? Those are going to be the key things that you're going to need to changing anything from polar to rectangular. You're going to need those at some point. Now, if you look at this, this says r equals 4 cosine theta. I really need an r next to cosine. So you know what you're allowed to do here? You're allowed to multiply both sides by r. So r is really like a radius, and a radius is not going to be 0, because like a lot of times you can't multiply an equation both sides by a variable because that could be 0. But we don't really care if it's 0 because it's r, it's a radius. So we're going to multiply both sides by r, and what that does is that gives me r squared equals 4 r cosine theta. Okay, now I'm ready. I'm ready already. Here we go. See this r squared? What does r squared equal? It equals x squared plus y squared. And do you see this r cosine theta? Do you know what that's equal to? It's equal to x. And then guess what? I already got it. Yep. If you were to subtract 4x to the other side, subtract 4x to the other side, this would be what it would look like. Okay? I don't know if you're used to it that way. Most of you guys are used to it as in you'd have to, complete the square and get it. This is just a circle. Once you complete the square and stuff, which you don't have to, but I want to show you that if you did, it would have been x minus 2 squared plus y squared equals 4. Do you know what that is?
No.
Yeah, I know you haven't done polar graphing in a while, but this is a circle with radius 2. See that? With center at the point 2, 0. Shifted 2 to the right. Y did not shift at all. And so it's a circle, and that's it in its rectangular form.
How do you know the center again?
Well, you would have to do the whole complete the square thing, which I'm not making you do. I'm fine with this answer way back here. I just wanted to show you because a lot of people look at that and they're like, that's not a circle. Because that's not what it looks like, what we normally do. Our circles normally look like this, but you can get that to equal that, but I'm not going to show you how because I don't really need it right now. Okay? All right, let's do another one, number 6. Running out of time. Let's do r equals 4 secant of theta. Okay. Ew is right. We don't like secant. Nobody does, right? Well, what is secant? Secant is 1 over cosine. We like that so much better. We don't like all those other ones, right? Now, let's take this and let's multiply cosine to the other side. And what do you get? You get r cosine theta equals 4. Well, r cosine theta is what? It's x. This is x equals 4. Do you know what that is? When you graph that, it's a vertical line, isn't it? So if I were to go to my polar graphing, and I did 4 over the cosine of theta, which is secant, I graph that, it gives me a silly vertical line. Kind of silly. All right, do I have time for this last one? Yes, 3 minutes. Number 7, last one. Okay, now we're going to go the other way. We have x minus 3 squared plus y minus 2 squared equals 13. All right, here we go. This is in rectangular form. I want to try to get this so that it's in polar form. Okay? It is a circle.
It is. Oh my gosh, it's Mr. Tiersman.
Oh, cool. Why are the bells? The bells are off today. That was the 7-minute bell. Ooh, that's going to be bad. Okay, anyways, let's move on. So what I'm going to do is this. I'm going to square this, and I'm going to square this. I'm going to FOIL the whole thing out. And I get x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals 13. Is everyone okay with that? I took this x minus 3 squared and I FOILed it out. Y minus 2 squared, FOILed it out. All right, so look what happens. I end up getting 9 and 4 is 13. I can subtract that over to the other side. And I get x squared minus 6x plus y squared minus 4y equals 0.
That's so. Oh my God.
Okay, now this is what I want you to do. You gotta do some rearranging. Get the x squared and your y squared together because we're going to replace that in just a minute. And then I have negative 6x minus 4y equals 0. Now what am I trying to do? I'm trying to get this into polar form. Polar form has r's and thetas. You're saying it.
Oh, so R squared.
Yes. So x squared plus y squared is r squared. What's x? I got to get rid of that x too.
R cosine theta.
R cosine theta. Perfect. And what's this one? R sine theta. Good. Equals 0. Okay, we're going to do a little bit of solving now. I'm going to add those guys over to the other side and leaving me with r squared. 6r cosine theta plus 4r sine theta. And you know what you're allowed to do, what you're never allowed to do?
What?
Divide everything by r. You know, like you're never allowed to divide by sine because it could be 0. Or you can't divide by x because it could be 0.
No, but R can never be 0.
R can't be, oh right, so we're going to divide everybody by r. And this would be our circle. That's it. No, that's pretty. Let's graph it. Oh, the bells were right. Well, you can graph it on your own if you'd like.